we're going we're going to talk about as well and about Samarco's implementation, which is a great case on the world currently. Jefferson, please keep it going.
Thank you very much. Thank you everyone for attending to our webinar. I hope you enjoy our presentation here. First of all, I would like to start here our presentation, welcoming everyone and presenting what is IntellTech. Okay, so what do we do here? As Luiz said, we are a software provider and we are focused on mining, environmental, and water dam segments. So our clients are mainly on the mining sector, but in the mining sector also they use on the environmental departments. Also, we have some electric generation clients, and we deliver this integrated, analytical, and intelligent monitoring system, right? This monitoring system is called integrated because we have this integration of the assets of our clients. So the client starts with some manual instruments, some automated instruments. Sometimes they also have some radars, generators, insert technology, some documents, right? So there are a lot of data sources, lots of files, lots of data to be integrated. So we start integrated everything. So this is an integrated monitoring solution, also an analytical solution, because as we're gonna see here, our solution has lots of modules for analytics, right? So it's possible to do stability analysis with our modules. It's possible to do some statistical big data analysis. There are a lot of analytical tools here on our solution that are available for our clients, and also intelligent because we have here some experts in IntellTech on data science, and their knowledge is embedded here on our solution, the SHMS, right? So there are these intelligent algorithms running backgrounds, right? And we talk about a business integration. So we start on the first level with this integration of the assets, but on a second level, we could talk about the integration of structures, integration between areas. For example, in Samarco, which is one of our cases here in Brazil, we have the integration between the geotechnical area and the automation area and the IT area. All three areas, the information flows much better right now that they have the SHMS installed there, right? So we're talking on a second level on this integration of the information between areas. And on an even higher level, it's possible with this solution to integrate all mining sites on the world. It's possible to monitor all the mining sites from just one single spot, right, on one single monitoring center. And from this center, it's possible to monitor all of the mining sites, and each site can monitor only their data. It's possible to configure that way because it's possible to control here which are the users who will be able to access each information, each module of the system, right? So it's a very scalable solution we're gonna present you. Also, we use this unique approach, the custom digital project, because this is a solution. It's not just a simple software that you can buy an off-the-shelf software and install it and run it easily, because we have to customize some information from for our clients. Each client has their own data, has their own routines, they have their own information, their own forms. So we have to do this custom digital project. So the solution adapts adjusts to the client, not the client has to adjust to the solution, right? Here are some clients of ours. So we have Samarco here in Brazil that on 2015 we had that terrible accident right on Samarco. After the accident, Samarco hired us to install our solution there. Also, the same happened to Vale. Vale here in Brazil in 2019 also had this huge accident in Brumadinho, and they also hired us after that. But we also have other clients such as Anglo American, MRN, CSN, also Light on the electrical sector. We have on Peru, Antamina, Las Bambas, and Tapacay. Here in Brazil, also Mosaic, using Minas. So these are some of our clients here, right? And here I can talk a little bit about what we call the solution, right? Why is it a custom digital project, a custom solution, right? It's not just a platform because we have the infrastructure service. So we provide the best infrastructure for our clients. If the client needs it to be installed on cloud, it will be on cloud. If it's a local installation, we can do a local installation. We can also do a hybrid installation. If the internet link is not very good on site, it's possible to replicate it locally to the cloud. Okay, we can also provide a SaaS as a service, right? So the best infrastructure for our clients. Also, we have some IT services where we can customize and develop new functionalities based on our clients' needs. So it's not like we develop everything we want to. We develop what our clients needs, right? Also, we have this integration service where we can integrate all of their instruments. It can be manual instruments, instrumentation that exports a file. We can integrate. We can automatically integrate with OPC technology, with databases. So we do this service to integrate with the client's instrumentation, with the client's assets. And also we do this historical data import into our software. So it's possible to import those files, that are like spreadsheets, Excels, old files you have with lots of old data. It's possible to integrate here on this platform. So everything will be standardized. Then we have the digital platform. That's why we have this custom solution. And after this deploying of the solution, we have the support service and also the maintenance service. So we have the support as our client needs. We also have the maintenance. So we are always improving our solution as we developed it. We are always improving new functionalities, designing new modules, and this new functionalities goes to our clients via this maintenance service. So what is the solution, right? The solution is called SHMS, the Slope Health Monitoring System. We start the slide here on the left. This is the reality, the assets our clients they have, right? So they might have satellite images, drill holes, images, 3D models from drones, files, weather stations, generators, automatic instruments, sirens to be activated when automatically activated when there is a dam break, for example, manual instruments, visual inspections. So there are a lot of data sources here. We start by integrating everything on the SHMS data lake. On this data lake, we integrate each data source here. Regarding the manual data sources, on-field data, right, gathered on field, we have the solution, the GeoInspector platform. With the GeoInspector platform, the user may go on field forms on a tablet, may insert the readings of the instruments on the tablet, and everything is synchronized, everything becomes integrated. By having all of this data, we can combine them to extract some information, to get some information from all of this huge amount of data. So the SHMS is this modular solution where it's possible to do 2D monitoring, where you can you can see all of the instruments on layers. It can be images, it can be satellite images, for example. It's possible to do this on a 3D monitoring where you can visualize all of the instrumentation with its alarms, with their alarms on a 3D model. There is the dynamic stability analysis where it's possible to calculate the factor of safety, the probability of failure, some stresses and strains using finite element methods, right? And it's dynamic because it's linked to the piezometers. So the water level will automatically change on time, and the factor of safety, probability of failure, will also change on time. So we are working here with a time series of factor of safety, right? Is a new concept. Also, there is the fault tree. With the fault tree, it's possible to combine different instruments. So, for example, if we have a structure, and on this structure we have 10 piezometers, let's say that only one of these 10 piezometers is in red alert. It's not that critical as if 8 or 9 of them are in red alert. This kind of logic we can construct here on the system using the fault tree. And depending on the combination, on the logic we construct here, we build here, we can activate the sirens. So we can create a logic here that will automatically detect when a dam break occurs. So if a dam break occurs, we can activate the siren automatically. Also, there is the instrumentation module where it's possible for the user to create some alerts, to create some formulas, sensors. It's possible here to monitor all the instrumentation with their technical data, variables. So everything will be integrated here regarding the instrumentation. Also, if you have some files, for example, photos, manual, installation sheets, calibration sheets, everything can be stored on the file drive. It works such as a Google Drive, OneDrive, but it can be linked to the instrumentation. So it's possible here with this drive to have besides all of the data from the instrumentation, you have all of their files inside the same platform, the same solution, the same system. There is also the documentation management where you can create a file structure of what is needed, for example, for a report, for a local regulation, and you can configure here the system to notify the people responsible for updating all of those files. So with this, our clients always have all of their regulation, all of their documentation required by a local regulation updated, always up to date. There is also the big data and predictive analysis. This is another analytical solution where our clients can create some dashboards with lots and lots of analysis. Here there are statistical analysis, correlation, forecasting of future measurements. It's possible to, here you can combine inclinometers, TDRs, piezometers, prisms. It's possible to do lots and lots of analysis here. Also, besides a dashboard, it's possible to create a template of a report, and this report can be automatically sent to the user's emails. So you can configure, for example, to receive every day a daily report of a structure on your email, right? And everything will be automatically done. The drill holes module here, it's possible to register on the system SPT, analysis, right? Also, there is the branch reconciliation, where it's possible to combine here two 3D models, the design of a pit with the scanning of the same pit. So it's possible to check the geometry of the slopes to see if the execution of the pit is according to the design. The same can be used, for example, for piles, wasting piles, right? There's also the static cross-section, where it's possible to create some cross-sections on the system. You can update the cross-section image and link to it all of the piezometers, wells, and it's possible to see the water level changing over time according to the new readings that are coming to the SHMS data lake. There's the risk maps, where the user can create some risk maps of, for example, falling rock risk, right? It's possible to create on the 2D. There is the activation of devices. Here we highlight the sirens, but it's possible to connect to a PLC and connect to other devices besides sirens. And also there is the Microsoft Office reports, where we have some plugins to export data from the SHMS to Microsoft Excel and to Microsoft Word. And we have this Power BI reports. We have an initial module of this Power BI that is working on Samarco, and we are expanding it to be commercialized soon also. So our clients will be able to connect to Power BI soon also. Talking a little bit about Samarco, right? Samarco in 2015 had that huge accident here in Brazil. So Samarco now is one of the has one of the most instrumented tailings dam in the world. That is Germanos. Yeah. So Samarco now it's a world reference on monitoring, right? And we have installed the SHMS there. So they have lots of instruments, pluviometries, water quality instruments, piezometer prisms, ground probe radars, inclinometers, shape axle arrays. And with all of this, they have this monitoring center. This is a screenshot, not a screenshot, but the system is here, right? Is a screenshot, a picture of their monitoring center, where they are using the SHMS here to monitor their solution. And here they are using the Geo Inspector, which is the tablet solution for on-field activities, right? So using this solution on the monitoring center, they can do this analysis, right? So they can use their technical and geotechnical knowledge to analyze all of this integrated information, right? And this can highlight some emergency operation, some alerts and right, some alarms, and can be used to forecast, to predict when an accident may occur, right? Also here, they do not use it only for one structure, to monitor one structure. They use it to monitor their tailings dams, and now they are starting to extract again, to work on their pits again. So they are starting to operate again, and they are monitoring their pits, their piles, right? So they are using our the IntellTech solution to monitor everything, every structure they have. Here we have some screenshots. We can see here the 2D monitoring with an analysis done here, everything integrated. This is the gel inspector, so they can monitor all of their activities on the map. They can use the tablet here to synchronize, to fill forms, to take photos on field, to follow up anomalies found on field, repairing actions, everything they can do with the gel inspector and the SHMS. Okay, so this is the slides, the presentation. I have here some screenshots of the systems. Oh, sorry. Okay, so we can see here, for example, this is a 2D monitoring screen where we can see some instruments here on a site. We can see here INSAR technology integrated. So we have all of the pixels of this INSAR technology here. We can see lots of other instruments. Also, there are integrated here other radars. It's just loading here. This is a gel radar from IDS. This is a point cloud of INSAR technology, for example, from this is Tre Altamira. We also have here some prisms, some wells, piezometers, right? Other instruments. And on this screen, this is just one of the modules of the SHMS. And what we have here is we can see a list of the instruments. We can change the alarm. We are seeing here, there's the operation alarm to see if the instrumentation are operative. We can filter here the instrumentation. We can also work with the radars. We can see the displacement, the velocity, quality information. We can change the gradient of the colors of the pixels. We can also see some risk maps, cross sections. It's possible to create some areas to work with the data from the radars. It's possible to here create some graphics. So if I click on an instrument, it doesn't matter if it's an automatic instrument, a manual instrument, a radar, we can work with it, right? We can select here a formula, a sensor, and create some alert levels for this instrumentation. Then we can create some graphics here just by changing here the period we want to see the graphics. We can refresh the analysis and we'll generate this time series graphic. But as I said, we have this experts on data science, right? So it's not only temporal series chart. We have here lots of different analysis, such as correlation, box plot, acceleration forecasting, data comparison, histogram, data properties, such as mean, standard deviation, minimum, maximum, skewness, kurtosis. On these tables, there is the measurement forecasting. There are lots of analysis to be done here. It's also possible to see the magnitude of the displacement of prisms, right? The arrays here, the vectors here, showing the displacement of prisms. It's possible to measure some distances here, right? Also, it's possible to use this screen as a monitoring screen. So I can push play here, and here's configured to 2 minutes. Every 2 minutes, this screen will refresh with all of new data. So it doesn't need human interaction to do so, and it can be used as Samarco is doing, use it on a monitoring center, on a television, for example, for monitoring. And this is one of our modules, right? The SHMS is available on English, Spanish, Portuguese, and French, right? So it can be used worldwide. Also, there are lots of modules here and sub-modules. I can show you, I'm gonna show you just some of this on this webinar. We won't have time to see everything, right? But I can show you some screenshots here. For example, we have this dashboard. This is the statistical analysis module, where it's possible to see here a dashboard with lots of graphics. All of these components we can resize, we can move, right? We can export data, we can download an image, and these are the analysis we have. So we have lots of temporal analysis to be done here, spatial analysis, correlation, sensitivity, prediction, descriptive statistics, box plot, histogram, tables, data monitoring, other here such as maps, radar, cross sections. It's possible to create all of this components here on the dashboard. We have here a temporal chart. We have a sensitivity matrix here, correlation graphic, correlation matrix. Also, there is the orthographic projection of prisms on the horizontal plane, where we can see here, for example, that both these prisms are oscillating here on with this azimuth approximately. This is an inclinometer chart where I'm showing here the ratings, the A plus, B, A plus, A minus. Let me open again here. We have the A plus, A minus, the raw data, but we also can do some correlation, some calculation with this information. So we may have the tube profile, the whole profile, for example. We may have the checksum and other calculations, such as, for example, everything that you can do with other inclinometer softwares, such as Inclinalysis, for example. It's possible to do with this chart here of the SHMS. There is also a map here. We are showing two prisms. They are the same prisms we're showing here with their magnitude vectors. It's possible to do some other analysis, such as a box plot analysis to see the historical data over time, cross correlations. This is a decomposition chart where we can see the trend here. We can see the noise. Oh, sorry, it's in Portuguese here. We can see the noise, the harmonics, a histogram, descriptive statistics table with minimum, maximum, mean, mode, median, standard deviation, right? Kurtosis, skillness, also text boxes, and the cross-section profiles, where we can see the piezometers here. There are levels of alert levels, right? And the water level here. As we click on the piezometer, we'll be able to see more information, the bottom and the color levels and the water level here. Okay, so also this dashboard can be seen on this on a report view, right? So it's loading here the report view that we can also export to a PDF, right? So we have here a PDF of this report, and this PDF can be configured to be sent by email for a group of users defined by the user, okay? So there are lots and lots of possibilities with this dashboard, with this module here of big data and predictive analysis. Also, there is the module here regarding this information. We can see, for example, the plugins for Excel and for Microsoft Word. So I have here on the SHMS a dashboard with only two components: a graphic here, a plot of this time series, and also a map. And as I use the SHMS plugin, I can export all of this data to the Excel, but also I can export the data to a Microsoft Word. So if our clients already have a report created on Microsoft Word, all they have to do is change their graphics to this components here using the plugin. And with the plugin, it's possible to refresh the data of all the graphics, right? So it's a very powerful tool for reports. There is also another module, which is the stability analysis module. Here, as I said, this module here links the sections, the cross sections, to the water table here with the instrumentation. So as we have everything integrated, the piezometers will refresh the water table level here, the water level, right? And we can do this analysis. We can configure this analysis to be run, for example, every 6 hours, every hour, or every day, with using this piezometric readings. As a result, we'll have almost the same as other stability analysis softwares. We can see here the factor of safety, right? The worst slippery surface here, the factor of safety. We can filter, we can see the material. If we have some external loadings applied here, seismic, also the instrumentation here, we have only one piezometer being used, which is the rating of it, the used rating, and the current rating. So we can do some past analysis also, right? And this is a deterministic analysis. It's possible to do this probabilistic analysis also, where we're going to see not only the factor of safety here, but the mean factor of safety for each surface. We can also have here for this simulation, the rupture probability here is 0. We can see the histogram of the simulation. We can also see some correlations, activity matrix. We have also some statistics of the simulation, such as mean, mode, median, standard deviation, variance, and others, right? Here we'll have this. This is an analysis here for the using finite element method. So it's possible to see here, for example, the total displacement of the nodes of the section, the stresses, the strain, plastic strain, right? So it's possible to see where the slip surface will pass here. Also, another module we have here is the bench reconciliation, where it's possible to compare the design and the scanning of a structure. We have here apart some slopes of an open pit, and we can see on red that the scanning the parts where the scanning is below the design, and in blue the parts where the scanning is over the design. So we can see here some excess of material, and here some missing material when compared to the design of the pit. We can also create this planes here. For each plane, we design the geometry, and the system calculates the geometry and color the planes here according to the berm width. So it's if it's a safe berm, it will be on green. If it's not safe, it will be on red. So on red, we may see some region where we have to do some repairing action, for example, right? And this applies not only for pits, but also for piles, right? Any kind of design of structures. There is also the fault tree module, where we can combine the alarms of the instrumentation. So here I have a fault tree created that combines, for example, the rainfall with the wells I have on the structure, with the piezometers I have on the structure. So I can combine using a logic for this instrumentation, I can create a groundwater alarm, right? I also have a surface displacement alarm where I have some prisms and some extensometers here measuring the surface displacement. And also an underground displacement where we might have some shape arrays, some inclinometers, some TDRs. This is just an example, right? And we can also combine here using another logic, combine the groundwater, the surface displacement, and the groundwater underground displacement. Combining this, we have the dam break alarm. If we have, for example, this dam break alarm here on red, we can activate a siren. We can do this for each of our structures. It can be done, for example, we can have a fault tree for each tailings dam. We can have a fault tree for sectors of a pit, for tailing, wasting piles, right? So it's possible to create this kinds of trees combining all of this information. This module here is the drive. So we have lots of folders, files, and we can link the files, the folders and the files to the instrumentation. So I can have a folder here regarding, for example, the vibrating wire piezometers. So I can upload to this folder the manual of those piezometers, and I can link this folder to the instrumentation. There is also this documentation management module where it's possible to create a file structure. This file structure can be regarding a regulation, regarding, for example, an environmental program, can be regarding a report, monthly report, for example. And let's say it's a monthly report, we can create this structure with all of the files we are gonna need on this report. Each of this file may need updated. So we can set here an expiration date, and we can notify the group, the person responsible for updating this file, and we can set here the notification. In this case, before the expiration date, 2 days before, it will notify the person, the group of administrators here, and this notification can be sent by email, by system, or by text message, right? Also, this is a dashboard of some sirens. We have here, we can see a log. In this case, I don't have a siren on my computer, right? So it says that the siren's not connected here, but we have this report. The sirens can be activated and deactivated directly from this module here. We can also have to the fault trees, right? As we have this dam break node to activate a sirens, we have the semi-automatic and the automatic activation. On the automatic activation, as this node becomes red, becomes on red alert, a pop-up will pop on the screen, and there will be a timer to cancel the activation of the siren. If nobody cancels it, it will automatically activate the siren. There is also the semi-automatic we call, which is the system detects that the siren must be activated, and this pop-up will pop on the screen, and we'll have some time to activate it. So it will not automatically activate the siren. The user must come here and click on the button, right? But the system will detect when it should be activated. So this is the device activation module, right? There is also the 3D where we can do the same analysis here, the monitoring, everything we do on the 2D. There is also this dashboard here regarding instrumentation. We have here some general information, technical data, the alarm levels. We have the readings of the instruments. So it's possible to have all of the information and the files of the instrumentation. And the system works with sensors and formulas the same way. So it's possible to create some formulas to link them to the alarm levels, right? So it's possible to create some formulas to smooth some data, and we can do all of the analysis and set alarm levels, alert levels to all of this sensors and formulas the same way, right? There are also other modules here. We couldn't we don't have much time to see, but there are lots of other modules here, and the other system, the Geo Inspector, where the user can go on field with a tablet and fill forms and gather all of the manual instrumentation readings, right? So we can see here some activities done on field. There's square markers here, marks places where there was an inspection done on field, right? There is also some round markers here where we can see the readings of the manual instrumentation done on field. It's possible to plan the activities using a calendar. It's possible to plan activities for work shifts, right? There is also the readings here with the Geo Inspector. It's possible to create some tables, some charts, to plot some charts, inspections, the inspection forms, any kind of forms. It's very flexible. So when the user comes here to this screen, they can edit the forms already created. They can create new forms. The forms have this structure, groups of questions. Each group has some questions. Each question has some entries. So it's if we can organize a form on this type, on this structure, it's possible to register here. It's possible to register, for example, text fields, selection, numbers, photos, comments, coordinates, date and time, multiple selection, and also signature. It's possible to sign the tablet also, right? So it's very flexible, very dynamic to create the forms. It's also possible to follow up all of the anomalies and recommendations found on field. So we'll have this table on field. The technician sees, for example, an anomaly, and a repairing action is needed for that region, right? For example, we have erosion on the access to tailings dam. So an anomaly may be registered here, and the supervisor can come here and attach an action, right? Link this action to the anomaly and say which, assign here this action to a department and to a person responsible inside this department. This person will receive an email so they can be notified that there is an action for for them on the Geo Inspector. There is also some reports here. It's possible to create reports regarding anomalies, adherence, for example, to check the planning and done activities on field, monitoring to see tables and graphics of the instrumentation. The forms is possible to print here, planning, the calendars, right? I'm just gonna create here a graphic, a report here using some graphics regarding the anomalies. So we'll have lots of indicators here, lots of KPIs, such as total of anomalies. This is in Portuguese because I have this Portuguese database, but this is the total of actions that are programmed, not programmed, and canceled actions. This is the status of the actions. We'll have other graphics, other tables. This is the actions by department. This is a table we have here. The amount of anomalies, opened anomalies, anomalies with a high or urgent levels. So there are a lot of graphics. We can interactuate with the graphics here. We can download them, right? So, well, it's a little bit fast, this seminar. We can schedule, if you want, you can contact us. We can schedule a more detailed presentation if you want, right? We are open to that. And well, thank you very much for this. We have some time yet we have 9 minutes. So if you have any questions, we are free to answer them.
Jefferson, thank you very much for your presentation. That was great again. And I'm apologize just because the time. We have a lot of other things to exhibit to you. You all here, but like Jeff was saying here, the time is a little bit short, and we could explore the stability analysis, dynamic stability analysis module. In other opportunities, you can explore the statistical and predictive module, which is a big, and others. But in general, you're talking about to make the integration and the statistics, big data analytics, and predictive analysis together, dynamic stability analysis together, fault tree together, the all analytics available to Excel and Power BI further. We're going to work on this that's moment, and to have all analysis from data from all fields. That's worth to say, and you can have it all integrated. Other point, what is important to say here, we work on your according to your reality. You make the integration contextualized, take into account your requirements, your specific needs, which is important to highlight, for example, the Samarco's case. Over there, we made the integration of the automation center, IT center, together the geotechnical sector, according its business rules, which is produce a great result, the intelligent, analytical, integrated monitoring and risk analysis of geotechnical structures. If you want to make questions, we are open to provide answers for you. Let's open for questions, please.
If you have a question, please unmute, and please you can ask a question. No questions? Come on, folks, don't be shy. So I will ask a question. So we are talking about two different systems. One is SHMS, and another one is Geotechnical. Am I correct?
Sorry, Elio, it was a little bit.
No, I was kicking up the questions just to clarify. We showed two different systems: the SHMS and the Geoinspector.
And the Geoinspector, exactly. The Geoinspector for the on-field activities and the SHMS to integrate everything, including the on-field activities.
Thank you. Yeah, the main system is the SHMS that has an ability to virtually connect every single source of data you have, meaning geotechnical instruments, geospatial instruments, radar, satellite, drones, whatever source of information you have. And then use this to traditional monitoring systems, but goes a lot beyond that. We can do analytics and predictive analytics calculations, as well as stability analysis. We can do those instability analysis inside SHMS. We have the capability to do it, but we can also interface with other analysis tools that you may have in your operation today. So we can work both ways. Am I correct, Jeff? You're in mute again, my friend.
Yes, that's correct. I think Jeff is with problems with his microphone. Jeff, can you hear me?
Yeah, sorry, I was muted here.
Okay, don't worry. Part of the process.
No, but that is it, Helio. Our solution until now, I don't think there is any kind of data source we couldn't integrate here. We've already integrated the main manufacturers of radars, georadars, for example, Hexagon, Ground Probe, MetaSensing, MetaSensing, Rytech, also the Instar Technologies, Telespazio, 3 Altamira, Darius, all of this information, manual information coming from manual instruments. There are some total stations, for example, that are not robotic, right? So you can download a file. There is also a module here where you can upload files, data upload files here, where you can upload this file. So weather stations where you can download a file, you can upload here. Any instrumentation you have, you can integrate here on the SHMS, and it's possible to work with its data and also transform its data, right, with formulas here. So it's a very flexible system.
Yeah, it's important to say. Oh, sorry, Jeff, because the connection was not good for me here. It's important to say every kind of data you can put in and put out from database from a slope health monitor system. You know, it's very flexible. You have developers team here that can make the producing API according to your reality, according to your business. You know, every single project that you have here, we made new APIs according the rules of needs of each client that you have. No, that's very flexible. So in summary, I could say you can make the integration from plant information. Basically, that's it. In addition, of course, everything that Jefferson Watts is exhibiting here. I can see there's people from Peru and Chile. We can change the language if you want that to produce responses nosotros podríamos contestar en español si necesitan. La gente de Perú o algo así.
I think the audience is very shy today, but yeah, you can ask questions in English, in Espanol, in Portuguese, you name it.
Hi, Jeff. It's Alain here I'm with Teixeira Altamira. One comment is every time I see you guys' stuff, I'm always super impressed. But I always have the same kind of question. And it's the SHMS is such an involved platform. It has like an enormous amount of modules and all that. Now, for when you implement this as a, let's say a new client comes in and is interested, can they customize this to only have a few, or do they have to sign up for the whole set? basically, cost effective in a way. So maybe not necessarily go for the whole gamut of modules, but maybe just a few to get going and test out the platform.
Oh, we are very flexible also with our selling. So let's say, for example, a user may want to use the SHMS only for tailings dam. Sometimes they don't want the bench reconciliation module. Okay, no problem. We can sell only the modules the client will use. The price will be according to the instrumentation they have, according to the number of sites they want to monitor. So it's a very flexible solution, right? Depending on the instrumentation, depending on the modules they want to have, depending on if they want to customize some modules, some new modules. We work with this hour contract, so a pack of hours, right? So the client may hire a pack of working hours from us, and we develop this new functionality, right? So it's very flexible. The idea here is that the solution may adjust to the client's needs, right? So it's the best fitting solution for our clients.
Yes, Alan, all infrastructure of the software, I'm talking about SHMS and Geospectrum, both of them have been constructed to support new features, new modules, new APIs. That was prepared for this. There's a new concept of the work. If I step into a new client, this new client have new features, new requirements. He wants to get some new functionality that he was not think about. That's it. That's the way. It's not just a fixed platform. The client needs to adapt to this platform. No, you're talking about the platform needs to adapt to the reality of each client. That's the point.
Yeah, it's important to know that every mining is unique by nature. So every mine, every dam, every customer you have is unique. And then the system is flexible to adapt. It's not one size fits all. And we are open to understand the customer requirements and necessary any development. Yeah, we are one of the few companies that normally do this in the market.
Well, our time is already over, so I would like to thank you all for attending to our webinar, and please contact us if you want any kind of information, additional information, additional presentation. We can work with it. Okay. So thank you very much, and have a great day.
Thank you all.
Have a great day, Guy. Thank you very much.
Thank you, Jefferson, and everybody.
Thank you, Alvaro.
I want to congratulate you on a very impressive bespoke system you developed. I've been following IntellTech from the start, and every time I see your presentation, I get more well impressed of all the work you've put on the system. So congratulations.
Thank you, Alvaro.
Thank you, Alvaro.
Again, just to find, we have this event being recorded and will be available for if you guys want to see at our website. Looking forward to hear from some of you and to follow up conversations. Thank you. Have a great morning, afternoon, and night for you guys.
And you, thank you.
Gracias, Helio.
Nada, Enrique. Juan.